Hello, good morning to everybody. Today, uh, physics 2, the electric in physics 2, electric charge and Coulomb's law. Electric charge and Coulomb's law. So, dear students, I hope this lecture uh, will will be very important for you because this is the first lecture in physics 2. So, welcome to everybody. So today, our topics will be electric charge and Coulomb's law. First of all, we must know about the electrons and protons and neutrons. This is the fundamental configuration and particles of atom. So you must know when electric charge produce, when we rub the rod with a silk cloth, then charge will be produced. And first of all, we discuss the historical, a brief history of the ancient uh, idea of the charge. First of all, ancient Greeks observed and identified electric and magnetic phenomena as early as 700 before Christ. They found that amber, when rubbed, become the electrified and attracted pieces of straw or feathers. Magnetic force are discovered by observing magnetic attracting iron. So this is the idea of ancient Greeks. And another one is William Gilbert in 1600 found that electrification was not limited to amber. That means first idea was with the amber and iron rod. Then in amber, you must know, is a special types of stone which produces charge when we rub with the rod. So William Gilbert gave another idea 1600 in 1600 found that electrification was not limited to amber. So Charles Coulomb in third phase, Charles Coulomb 1785 confirmed the universe square relationship of electrical force. That means gravitational law and the law of attraction of any two charges will be the comparable. That means there is a relationship between two universal law and the charge between force between the charge. Now, final history, Hans Oersted in 1819, compass needle deflect when placed near an electrical current. And in 1831, Michael Faraday, a wire moved near a magnet and electric current is observed in the air. That means electromagnetic force produced. And at last, we are using this concept in our fan. Fan is moving with the help of electromotive force. And computer, in computer, we are using electromagnetic force. And you are hearing my lecture with the help of electromagnetic force. So at last, James Clerk Maxwell, 1865 to 1873, formulated the laws of electromagnetism. And this is the actually complete theory. And Heinrich Hertz in 1888 verified Maxwell's equations. So properties of electric charge, two types of charges exist. They are called positive and negative. And it's named by Benjamin Franklin. You must know about the Benjamin Franklin who gave us milestone idea of electric charges. So the concept of electricity and magnetism, actually static electricity, you must know when we touch metal with another parts of metal or iron rod, we get the static electricity. This is the physical and real life example of static electricity. And another one is current electricity. You must know we can use battery to light to give in a bulb. So this is the example of current electricity. Another is magnetism and electromagnetism. Using these two, current electricity and static electricity, we can find the magnetism and electromagnetism. So this is the actually magnet to produce electromagnetism. So the electrical charge carrier, the electron negatively charged, and its charge amount of charge will be 9.11 into 10 to the 1 minus 31 kilogram. And the proton, you must know, positively charged 1.67 into 10 to the 1 minus 27 kilogram. And this is the whole atom, and center is the actual nucleus. You must know this is the nucleus. So, and these are electrons surrounding and moving around the nucleus. So this electron, the mass of this electron will be 9.11 into 10 to the minus 31 kilogram, and the proton, positively charged, which lies in the nucleus of an atom. So this mass will be 1.67 into 10 to the power minus 27 kilogram. So why is electron principally responsible to determine the electric charge? Why? This is a great question for us. So charge basic, opposite charge attract, you must know, negative and positive charge will attract each other, and like charge repel each other. That means don't attract. Like charge means positive positive or negative negative charge will repel each other, and electrons and protons have equal and opposite charge, you must know. So the lowest possible charge is that of electrons or proton. No fractional charge uh, discovered or invented yet. So lowest possible charge is that of electron or of a proton. Now we are talking about the last man in the historical background of electric charge. This is the Benjamin Franklin, his lifetime 1706 to 1790. Famous kite experiment, first to give charge the name positive and negative. So this is the father of electric charge who has given the name of positive and negative charge. First to realize the law of conservation of charge. That means charge cannot be created or destroyed. It's just transfer from one place to another place. That means from one body to another body. So he first realized this important loss of conservation. That means the loss of conservation of charge. Invented the lighting rod. He also invented the lighting rod. And it is a great milestone for the electric charge. And you must know the SI unit of charge, the Coulomb. You must know the what is Coulomb. Okay, 6.25 into 10 to the power 18 electrons or protons are needed to make Coulomb. The charge on the single electron or proton 1.6 into 10 to the minus 19 Coulomb. We can use the reference table. You must know another great man, Charles Augustine D. Coulomb. We are talking about the Coulomb's law. His lifetime is 1736 to 1806. It is his photograph. So there is a question, how does an object become negatively charged? How does an object become positively charged? What is the net charge in coulombs of 5 electrons? What is the number of protons that make up to a charge of 10 nanocoulombs? Okay. So loss of conservation of charge. Electric charge can neither be created nor destroyed. Just it can transfer from one place to another place like that. Okay. Minus it, plus it. On the other hand, it was -5. There are 5 electrons and there are 11 electrons. When they are come to each other, then it become mi -8 -8 electrons. That means in previous some electrons comes here. That means 3 electrons. Okay, come to left vertically. Okay, so another two chairs, one marked as red, another is white. So this is the neutral charge. Okay, so we can represent this -8 and -8 like this. So transferring charge, we can transfer if we rub your hair, especially at winter season, with a comb, then we get another an invention of electric charge. But if we place some papers, some piece of papers, then this comb will attract to each of the piece of paper. So that means electric charge produced here. Okay, and this is the electroscope, a device used to detect electric charge, whether it is positive or negative. Now, the important properties of electric charges. Two types of charges exist. They are called positive and negative. We already know, which is named by the Benjamin Franklin. Unlike charges attract one another, and like charges repel each other. So you must know, if we this is a rubber and a glass rod. So if we take them to each other, then it will be uh, attract each other. And another is rubber, and rubber will be repel each other. So this is the important properties of electric charges. Now, properties of electric charge. Electric charge is always conserved. That means electron can never be created or uh, destroyed. So this is the conservation laws of charges. Charge is not created, only exchanged. Just it change its position from one substance to another substance, or one object to another object. Now objects become charged because negative charge, or that means electron, is transferred from one object to another. This is the another example, real life example of electric charge. When we rub the glass rod with a silk cloth, then it will be charged. Now, nature's basic carriers of positive charge is the proton. Proton rarely move from one material to another because they're held firmly in the nucleus. Because its position, the position of proton is in nucleus. This is why only electrons can transfer from one object to another. And nature's basic carrier of negative charge is the electron. That means gaining or losing electrons is how an object becomes charged typically. Now, charge is quantized. All the charge is the same multiple of a fundamental unit of charge. That means Q equals to any, where quarks are the exception. Actually, this is the very modern idea of quarks. Quarks is the very modern idea of physics. Another is electron have a charge E, that means negatively charged, and proton have a charge positive E. You must know this is the fundamental idea of electric charge. Now, the elementary particles, charge and masses, you must know about this. Electron, this will be charged 1.6 into 0 10 to the minus 19 coulomb, and mass will be 9.11 into 10 to the minus 31 kilogram. And proton a little bit heavier than electron. The charge will be 1.60 into 10 to the minus 19. Same charge, but mass will be a little bit heavier than electron, 1.67 into 10 to the minus 27. So, but neutron, this is the neutral particle of atom. So the charge is zero. Yes, charge is zero, and and mass will be 1.67 into 10 to the minus 27 kilogram. That means the same as the mass of proton. So if we take a quiz from you, if you rub an inflated balloons against your hair, the two materials attract each other. Is the amount of charge present in the system of the balloons and your hair after rubbing? That means less than, the same as, or more than the amount of charge present before rubbing. So this is the question in front of you. I hope you will think about this question and give answer for the next day. So actually the answer will be the same. I hope you will think, because if you wrap these two materials each other, then uh, the there will be same system. Now conductors, you must know, to carry the charge, you must know we need another materials which is called conductors. Conductors are materials in which electrons move freely through the material. That means copper, Cu, the symbol, aluminum, Al is the symbol, and silver, as is the symbol, are good conductors. You must know. When a conductor is charged in a small region, the charge readily distributes itself over the entire surface of the conductors. Suppose this is the conductors, a piece of conductors, and electric charge will be entirely lies in the whole region of that conductors. Now, what will be the insulator? Insulators are materials in which all electrons are bound to atoms and cannot move freely through the material. That means glass and rubber are example of insulators because electrons cannot pass through these two, glass and rubber. Okay. When the insulators are charged by rubbing, only rubbed area becomes charged. Remember it. If you use to rub, that means to produce charge by using insulator, only the rubbed area becomes charged. There is almost no tendency for the charge to move into other region of the material. Okay. Now another materials which lies between conductor and insulator, that means semiconductors. The characteristics of semiconductors are between those of insulators and conductors. That means silicon and germanium are the examples of semiconductors. You must know the electrical properties of semiconductors can be changed over many of order magnitudes by the addition of controlled amount of certain atoms to the materials. And this method is called doping, because in many cases you have to use semiconductors in every electric machines, computer, and TV, freeze. In every hire we have to use semiconductors so that the high voltage of electrons, that means high voltage of electrons cannot pass through in it, and so that it cannot be destroyed by the use of electricity. So charging of conductors, a charged object, that means the rod, is placed in contact with another object, the conducting sphere. Suppose this is the conducting sphere and this is the rubber. If we touch, this is the before mm, picture, some electrons can on the rod can move to the sphere. That means from rod move to the sphere. So after when the rod is removed, the sphere is left with a charge. Okay, that means from rubber some charge attracted by the sphere, then so the sphere get move. If we remove the rod, then charge will be distributed to the sphere. But before, in the previous figure, we observed that the rubber, if we contact with rubber and sphere, then charged will be attract each other. Okay, but if we remove the rod, then charge will be distributed equally in the whole sphere region of the sphere or hand rod. The object being charged is always left with a charge having the same sign as the object doing the charging. Now charging by induction process. This is the very important process for you producing charge. A negatively charged rubber rod is brought near an uncharged particle. Okay, the charges in the sphere are redistributed. If we replace this rod, then it will be redistributed, and positive negative positive negative. Oh, okay. Now charging by induction process, we can the region of the sphere nearest by the negatively charged rod has an excess of positive charge because of the migration of electrons away from this location. A grounded conducting wire is connected to the sphere, allows some of the electrons to move from the sphere to the ground. So this is the charging by induction, and the wire to ground is removed. The sphere is left with the excess of induced positive charge. Okay, and the positive charge on the sphere is evenly distributed due to the repulsion between the positive charges. Okay, there are positive and there are many negative charges, and they attract each other. Okay, but if we remove this rod, then all positive charges will be redistributed to the whole region. So charging by induction requires no contact with the object inducing the charge. Now charging object and the most neutral atoms are molecules. The centers of the positive charge coincides with the center of negative charge. In the presence of the charged object, these centers may separate slightly. Suppose this is the insulator and this is the charged object. Charged object is positively charged, and insulator positive negative equally distributed. So this results is more positive charge on the one side of the molecule than other side. That means positive charge, and on the other side only negative charge will be placed, distributed to attract the charged object. So this is the actually real life example of charging objects by induction process. And this realignment of charge on the surface of an insulator is known as polarization. That means there are two pole produces, one is positive and other is negative pole by the induction of charged objects. So this is process also called polarization. So this is the real life example of polarization. Now an example of polarization: a charged comb attract neutral but polarized bits of the paper. Okay, some papers attracted by the charged body, that means comb. So this is another real life example of polarization. Now we are waiting for the most important loss of charged electric charge, that means Coulomb's law. This he is the a great scientist, and the Charles Coulomb, his lifetime 1736 to 1806. He measured the magnitudes of the electric forces between the charged objects using the torsion balance, which he invented. Okay, he's the founder of the a famous law, Coulomb's law, which is called. He used this torsion. He used this machine used for proving the Coulomb's law. The electric forces between the charged spheres A and B. There are two sphere A and B, cause the spheres to either attract or repel each other. The resulting motion because cause the suspended fiber to twist. That means the fiber will be twisted. A measurement of the angle of the twisted providing a quantitative measure of the electric force. So we'll use the term point charge to mean a particle of zero size that carries an electric charge. Now Coulomb's law: an electrical force between 2 point charges has the following properties. It is inversely proportional to the square of the separation R between the particles and the direct along the line joining them. It is proportional to the product of the charge Q1, which may be positive or negative, and Q2, absolute value of Q2, that means amount of charge will be Q2, second charge body, that means this will be negative or positive on the two particles. It is attractive if the charges are opposite sign, and the repulsive if the charges have the same sign. You must know about this. So this is the mathematical representation of Coulomb's law. So the force acting force on the two particles Q1 and Q2 will be Fe, and Fe is the F equals to Ke Q1, but first charge Q1 and second charge Q2 divided by distance between them whole square. Then and K is called the actually Coulomb's constant. You must know this can be represented by the 1 by 4 pi epsilon naught. The value of Ke depends on the choice of units. The SI unit, standard units, the charge will be Coulomb. The Coulomb constant Ke equals to 8.99 into 10 to the power 9 Newton meter square per Coulomb square. So this is the very important constant which is called Coulomb constant in the Coulomb's law. Now back to nature of electric force. Suppose Q1 is the first sphere and Q2 is the second sphere amount of charge. Their distance between is R. So suppose this is the positive charge and this is the positive charge. So this will be repulsive force. So F21, that means F21 will be this force and F12 will be the force from Q1 to Q2. And F21 will be from force Q2 to Q1. So you must know by the Newton's law of forces, you must know these two forces will be, sum of these two forces will be 0. That means F12 equals to minus F1. So the like charge produces a repulsive force between them, and the force on Q1 is equal on the magnitudes and opposite in the direction of the force Q2. That means F12 equals to minus F1, F21. So sum of this force will be balanced. So another vector nature for the opposite charge, if you take 2 point charges are separately by a distance r, the unlike charge produces attractive force between them. The force on Q1 is equal to magnitudes and opposite in direction to the force on Q2. That means Q1 force acting from Q1 to Q2, and another force F2, F will be acting from Q to Q1. That means this F21, F12 will be attractive. So total force will be F21 plus F12. So this is the this force is this is the unlike charges. This is why attractive force will be acting here. Now electric force. What is the electric force? This is the second example of field force. Gravity was the first. So a field force, what will be? The force is exerted by one object on another object, even though there is no physical contact between them. So suppose there are two charges, one is Q1, another is Q2. The force between these two charges, either it is repulsive or attractive, this force will act in a fixed field. That means in the fixed region. So this is called actually field force. There are some important differences between electrical and gravitational force. You must know the electrical force compared to the gravitational force, both are inverse square laws. Okay, both are inverse square, same laws. The mathematical form of both laws is the same. The electrical force can be either attractive or repulsive, but gravitational force are always attractive. We must know, because in the whole universe, in every bodies attract each other. Suppose any ant, one ant can run in the wall, okay, but man or we cannot run on a wall because our mass is very high, but the mass of ant is very negligible. This is why they can easily climb the wall, but we cannot. So, and this force will be the gravitational force, because an ant attract to the wall easily. Okay, so the mass of wall is very high, but the mass of ant is very low. This is why their attractive force will be actively, and this force is called gravitational force. So this is the actually electrical force compared to the gravitational force. So the electric charge produces electric force. A key question here, how do electric charges interact? So electric force, you must know force between Q1 and Q2, attractive force, because the opposite charge, capital F equals to 1.8 into 10 to the power 25 Newton. But the gravitational force of the first charge, first body M1 and second body M2 will be 6.7 into 10 to the power minus 11 Newton. So these two forces are different. First one is electric force, second one is gravitational force. So all ordinary matter contains both positive and negative charge. So you do not usually notice the charge because the most matter contains the exact same number of positive and negative charge. That means all maximum bodies acts as neutrality because there are same number of positive and negative charge. So an object is electrically neutral when it has equal amount of both types of charges. That means this is the neutral because there are positive charge A plus 8 and negative charge minus 8. This is why this object is neutral. So object can lose or gain electric charge. Uh, the net charge is also sometimes called the excess charge because the charged object has an excess of either positive or negative charges. A, a tiny imbalanced in either positive or negative charges in object is the cause of static electricity, must know. So this is the example of static electricity. That means the charge cannot move. So electric charge is a property of tiny particle in atoms. You must know about this. The unit charge, electric charge of is the Coulomb. A quantity of charge should always be identified with a positive or negative sign. So the mass of electron, you must know, and the mass, the charge of this, we have already shown it. So the structure of an atom, you must know, this is the nucleus, and electron cloud. This is the electron cloud, and these are electrons. This is red sphere and denote the electrons, and this is the nucleus. Proton and neutron lies in the nucleus. Now electric force are created between all electric charges because there are two kinds of charge, positive and negative. So like charge repel each other and unlike charge attract each other. So neutral electroscope, because the insulator and metal rod and ball produces the same number of positive proton and neutron. This is why neutral. And positively charged, you must know, because this electroscope will be positively charged. Okay, positively charged. So charge can be transferred by induction process. And this is the positively charged, and this is the negatively charged. By induction process, we can produce this by electroscope. So what is the electric current? The direction of current was historically defined as the direction that positively charged move. Actually, we can define the electricity, actually the movement of charge, whether it is positive or negative. So the electric current, two ways to make current flow from positive to negative. Negative charge moving to the left, okay, and positive charge moving to the right. We have to remember this historical direction of current, and everybody knows this one. Negatively charged moving to the left, remember it, but positively right, that means opposite. So both positive and negative charge can carry current. We have to remember this concept. Both positive and negative charge can carry current. So in conductive liquids, salt water, both positive and negative charge carry current. This is the example for conductive for electric current. That means if we take a salt water in a conductive liquids, the both positive and negative charge carry current. In solid metal conductors, only the electrons can move. But you have to remember that all in solid matter, only the electrons can move. So current is carried by the flow of electrons. That means you are using where and you are hearing my lecture and watching my lecture with a computer. So all are carried out by the negatively electrons, the negative charge. But in chemical reaction, in chemistry, electrolysis process, the conductive in a conductive liquids, salt, that means salt water, both positive and negative charge carry current. We have to remember this concept. So current is the movement of electric charge through a substance. So I equals to what will be taken? The carrying amount of charge in a per unit time is called current. Amount of charge in a per unit time is called current. So current can be measured by ampere, I equals to Q by T. So charge that flows in Coulomb and time in second. So this is the current, electric current. You can calculate the current, calculate the current 2 coulombs of charges pass through a wire in 5 seconds. Calculate the current in the air. You must know conductors and insulators. About this we must know. Okay, the electrons are what carry current, the conductor, atom in a conductor and moving electron, because it is solid. The electrons insulators are not free to move. They are tightly bound inside the atoms. This is why in insulator there will be no flow of current. Okay, this is the example of an atom in an insulator in where the charge cannot move. So a semiconductor has a few free electrons, atoms with bound electrons that acts as an insulator. Okay, this is the conductor, and this is the current, and this is the semiconductor, and this is the insulator. So this we can differ these three types of uh, materials in where electron passes through. So this you must know about the flow of electrons in these three types of materials. So moving electrons, okay, atoms in a conductor tight with the nucleus. That means in insulator, electron cannot move. So atoms in an insulator like this, atoms in a conductor like this, and moving electron is this. So in conductor, we are observing the moving electrons, but in conductor, atom in a conductor like this. Okay. So atom in insulator will be this. That means no flow of electrons. When two neutral objects are rubbed together, charge is transferred from one to the other. The objects become positive charges. You have to remember this. That means balloons and other one is rubber. So this is called charging by friction. So objects charged by this method will attract each other. And you must know this is the another example of polarization. This is the balloons and this is the insulator. If we charged balloon, this is the negatively charged. So if we place these two with a contact each other, then a polarized will be formed. So this is the Coulomb's law where we are defining. The Coulomb's law relates the force between two single charges separately by a distance F equals to 10 into Q1 by Q2 R square. That means this is the force and this is the constant 9 into 10 to the power 9 Newton meter square per Coulomb square, and this is the distance and this is the charges. There are two charges. So Coulomb's law can be seen as like this. So force F equals to A into V1 by Q2 R square. This is the distance. So Coulomb's law, what will be the Coulomb's law? The force between two charges gets stronger as the charge move closer to the force also gets stronger if the amount of charge become larger. Okay, that means depend on the amount of charges. So the force between two charges is directed along the line connecting their content. Electric force always occur in pair according to Newton's third law. You must know, like all forces. So according to the Newton's third law, this is the attraction of forces and repulsion. So the force between charges is directly proportional to the magnitudes or amount of each charges. Okay, directly proportional to the amount of charges and magnitudes also. The doubling one charge doubles the force. Remember it. If we make the charges double, the force will become double. That means like this. Okay, doubling the forces. Doubling both charges, what will be force? 4 times, quadruples of the force. That means like this. So according to the Coulomb's law, we can define the force between charges inversely proportional to the square of the distance between them, and doubling the distance reduces the force by a factor of 2 square, that means 4 times. So decreasing the force in 1/4 of the original value will be 1 value, like this. This is the first one and this is the second one. Okay, if distance doubled, then force will become 1/4. Remember this by Coulomb's law. So the relationship is an inversely square law because force and distance follow an inverse square relationship. So we can calculate the force. Two balls are each given a static electric charge of 1/10,000 of a coulomb, like this. Then calculate the force between the charges when they are separated by 1/10 of a meter. Compare the force and weight of an average 70 kilogram person. Okay, so you are asked to calculate the force and compare it to the person's weight. You might given the charge of separation and mass of the person, use Coulomb's law, F equals to minus K Q1 Q2 divided by D square for the electric force and F equals to mg for the weight. And we can solve. F equals to what will be 9,000 Newton. Okay, just putting the values of charge and distance and the Coulomb constant 9 Newton or 9 Newton meter square per Coulomb square in the Coulomb's law. We get force, electric force, what? 9,000 Newton. The weight of 70 kilogram person will be what? 686 Newton. So the force between the charges is 13.1 times the weight of an average person. Remember it. How many times? 13.1 times. Electric charge will be more and more. So field and forces. The concept of field is used to describe any quantity that has a value for all points in space. You can think of the field as the way forces transmitted between the objects. Charges created electric field that creates force on other charges. That means this is the charged particle, negatively charged, and this is the field, electric field. Charge creates an electric field. The electric field exerts force to other charges. Due to this field, other charge will be attract or repel. So mass creates a gravitational field that exerts forces on other masses. Okay, this is the earth and this is the gravitational field, and the mass of the earth creates a gravitational field, and the gravitational field exerts a force on the moon. That means in the universe, in the universe, we must know any two bodies attract each other. It's either planet or star, any star. Suppose a favorite star, sun, and a favorite planet, Earth. So the attraction between the Earth and Moon will be measured by the gravitational force. So the gravitational force are far weaker than the electrical force. We have proved already the which is weaker. We must know gravitational force is more weaker than electric force. We have calculated with an example. So drawing an electric field, field lines point towards the negatively charged and away from positively charged. Remember it. Towards negatively charged, that means force coming from other parts to the negatively charged, but like this. So away from positively charged, and entering to the negatively charged. Remember it. So from positive charged body, electric line of force will be coming from. That means away from positive charge and away from positive charge. So this is the actually example of drawing the electric fields. So drawing an electric field lines. This is the we have to imagine these lines, negatively charged body and imaginary positive test charge. Another, if we place another test charge, that means positive one. So this will be a line of forces will away from where positively charged and entering to the negatively charged. So the field lines show the force on a positive test charge. Field lines always point away from positive charge and towards the negative charge. The spacing of the lines indicating the strength of the field. So electric field and electric force. So we can on the Earth's surface, the gravitational field creates 8 Newton of force on each kilogram of mass. With gravity, the strength of the field is in newtons per kilogram because the field describes the amount of force per kilogram of mass. That means field, gravity field and electricity. Gravity field what will be? Newton per kilogram. But in electricity, Newton per coulomb. So we have to, we can represent this as an equation F equals to mg and this will F equals to QE. So this F will be the electric field. Remember it. So with the electric field, the strength is in newtons per coulomb, and the electric field describes the amount of force per coulomb of the charges. So this is the electric field and another is electric force. So fields and force, this is the example for gravitational field and this is the electric field. Remember it. There are two types of field. Another is gravitational field, another is what? Electric field. Electric field creates the from where? Charged particle, positive, negatively charged and positively charged. You must know negatively charged coming the line of forces, but in positively charged away of the lines. So actually this is the discussing we are the Coulomb's law and the electric field.